Hello, friends. This is Krish here. Good evening, good morning, or good afternoon, wherever you are. And today, as promised, I'm here to present a live case on linear regression forecasting. So, it's a linear regression forecasting, and we'll be using a tool called Python. So, I guess that we all have heard the word Python, and Python has become very popular these days, and this is the most popular tool being used for programming. And so the Python is also used for machine learning, predictive analytics. So Python is also going to become very popular for supply chain professionals. If supply chain professionals, if they develop a expertise on the Python, then I think they will have very high leverage. They will be appreciated. They will be given a lot more weightage. There will be a lot more weightage in terms of high and off. So before with so we without wasting time, I would like to move into the case study. So before going to case study, I want to discuss that I am now with how to download, how to install the Python and all. You have to go to the Python website. You have to go to the Python website, and from there you have to install the Python. And there is other Anaconda Navigator. You can go to Anaconda. This is the Anaconda platform. From here, there are various kind of IDEs are there. So I can use Python in Jupyter Lab or Jupyter Notebook or PyCharm Professional. So this is the Anaconda.navigator, which you have to download from the internet. And from once you download this Anaconda Navigator, before that you need to have the Python installed in your system. And then you can use the Python using Jupyter Lab or Jupyter Notebook. So I'm using Jupyter Notebook. Okay, so just you have to use the Python in Jupyter Notebook. You have to click on Launch. You have to click on Launch. Once you launch, you'll get it is going to open. So this is going to open your local host in your web browser like this. Right. So now once we are into this page, Jupyter, and Jupyter is a platform where you can actually, you can write codes and create outputs. So before moving into this exercise, I will tell you what I am going to do in this exercise. So I have already mentioned that you need to install Python from their website. And you should install the latest version. So once install this Python, the latest version, so once you install the latest version Python, then you have to go to Anaconda Navigator, install this, and from the environment of Anaconda, you can use Jupyter. lab or Jupyter notebook. Okay. So we're going to use Jupyter notebook. We can also use Jupyter lab to get the same outcomes. So we're going to use Jupyter lab. So you have to go and click on launch. Once you launch, once you launch Jupyter notebook, you will go into the environment. So the first step, this is for installation. Now after the installation, we need to, if you want to work on a machine learning algorithms, we need to install packages. What are the packages? Suppose I'm working on linear regression. Linear regression is is one of the forecasting technique. It's also called causal base, cost based, or single cost base forecast. Suppose we have sales. We want to know why the sales are increasing or decreasing. The sales is our dependent variable or outcome variable, right? We want to know why sales go up and why sales go down. And also we want to know if sales go up, what is that value? If sales go down, then what is that value? And we also want to know why the sales go up and down. We want to know why the sales go up and down. So if you want to know why sales go up and down, then we need to understand the reason. And that reason is called cause. And this is also called independent variable. Or we can also call this as a predictive variable. Right? So why the sales go up and go down, that is cause. That cause is also called reason of sales or independent variable or predictor variable. So this is the linear regression helps us to build a relationship, model a relationship between the cause means the input and outcome is also called effect is the output. So what is the output here? Sales. What is the input? Let's say time. So I want to know how the sales go up and down. So let me say my y hat is equal to forecast. So y hat is equal to what is my input time here, right? So let's say I'm having some constant here, alpha plus, right? The coefficient of time into time plus some error. So this is what the equation we need to generate to predict why the sales go up and down. So this is what your output, the sales forecast. So y hat is equal to your sales forecast. So why the sales go up and sales go down? We want to model that relationship with respect to some time. So y is equal to, I'll write in the simple form beta into t plus some error. This error is coming because our model is not completely mapping our model is not able to completely map the historical sales. Right? So model is not able to completely map on the historical sales. So this is what we want to predict. So these are to predict this, what we want is packages. What are those packages? NumPy, Pandas, SkyKit, SkyPy. These are four packages I'm going to use to perform linear regression. And I'm going to predict the y hat. I'm going to predict mean square error. I'm going to predict mean absolute percentage error. I'm going to predict R2 R square. I'm going to predict t value. I'm going to predict p value. Right? So various things will predict, and these are all the metrics of how the model is, how strong a model is. We'll try to know how strong the model is by looking at these metrics, and we have to predict our forecast. That is what y is equal to y hat is equal to alpha plus beta into t plus error. Right? So this alpha plus beta is mine, and this error. This is what error we are predicting from here. And this is my y hat. So let's start the process in the Jupyter. So this is my Jupyter, which will open after I click launch button in the Anaconda navigator. This is my navigator. If you click on this launch button, we'll go inside this localhost in the web browser. The first thing, I have to install the packages as I mentioned. So I have to install the packages. NumPy, Pandas, Matplotlib. So Matplotlib is a package for making graphs. So we need to also make graphs. So we will be taking Matplotlib. So I'll click Shift and Enter to run the code. The code is running. And then I will import if you look at here, import numpy sp np. So we are going to use np as the code to fetch the packages or the functions or features from NumPy. We're going to use PD as the code to fetch the features and the functions from the pandas. We're going to use PLT as a plot. PLT means plot to draw the plots, various plot features from the matplotlib.py plot. So I'm going to fetch linear regression model from scikit-learn. I'm going to fetch metrics like mean, absolute, percentage, error. This is also called mean. I'm going to fetch R square. I'm going to fetch mean squared error. I'm going to fetch mean absolute error. So I got a error in somewhere. Let's see. So this is not SC. This is SK. Now still we got an error. Let's see what is the error. Cannot import name R2 underscore square. This is 4, I think. Okay, so let's rectify our errors. So now we have no errors now. So this is R2 not square. This is R2 underscore score. I mistyped it. So now we have done, or we have to do one more import. So from SkyPy, we are going to import stats. So this is the basic imports we have. This is the basic installation and imports we have to do if we want to run linear regression. So first we have to import NumPy SNP, import pandas as PD, import matplotlib.pyplot as PLT, and from Skyline we need to import linear regression. From Skyline we need to import metrics like mean absolute percentage error, R2 score, mean squared error, mean absolute error. Right. These are the metrics we need to export from the Skylab. So this is what we need to mention in the beginning. And also I'm going to import stats. This is stats is a function which is used to create PDF, probability density function, cumulative density function. So for that I need this particular thing. So I'm importing from SkyPy this. Now I'll define my data. So what is data? Let's say I'll say data is equal to, I need to fetch a data from the system. So pd dot read underscore Excel. I'll write R, comma, okay, and I'll go to an Excel file and copy the path from there. So I have data already with me, like modeling under 3. I'll open this data and I need a file path of the data. So this is copy path to clipboard. I can cancel this and go back to the code, and I'm going to paste here the path and put exclamation So this is the file which I'm trying to access from my system. I'll run this. So I'm getting some error here. Let's see what is the error. Excel file one cannot be determined. You must specify an engine manually. So this path is not right. Let's go back to the file again. Let's run the code again. This time I think this is working. So pd dot. So if you have the file and you want to import that file into Python, and the file is in Excel format, you have to mention the code pd.read_excel. Then you have to write R. This R is because Python considers this back. Python wants, suppose if I remove this R from here, this will not run. This is an error. The error is that this is a backslash. So the backslash is not read by not is not able to Python does not Python doesn't read the backslash. If I make this backslash into double backslash everywhere, and if I run the code, this is working. So either we need to put double backslash, or if you want to put single backslash, then we need to put R. This is able to run. Or we need to convert this backslash into forward slash. So the Python can read either the forward slash or double backslash, or if it is a backslash, then we have to put R in front of the file name. That is a condition. So pd.read underscore Excel, because our file is in the Excel format. So pd.read underscore Excel, this is what we need to give the file path. Now we have the file. What is in the file? I want to see what is in the file. So I'll just take top 5 lines. So this is in the file, and I'm getting the top 5 lines. If I want to see the bottom 5 lines, I'll write d.tail and run the code. So this is I'm going to see the bottom 5 lines. Also want to see what is number of rows and number of columns in my file. Look at here, I have 344 rows and 15 columns. I have 344 rows and 15 columns over here. This is my data size. Now, so in linear regression, we have to define what is my cost variable and what is my effect variable, or what is my input variable and what is my output variable. So I'll write my x as the input variable. So what is the data? D. And I give my input variable as time, sequence. Here it is sequence. Sequence, right? And I'm going to give my y variable also. And the y variable is the auto sale underscore trend. So I have defined my cause variable and my effect variable, or input variable or output variable. I have defined both of them. So I see some error over here. Let's see what is that error. If you see, I didn't put here apostrophes. Now the code is working because I didn't put apostrophes earlier. So now I'm putting apostrophe over here. So I defined my x variable and my y variable. Right now, I have defined what model I'm going to use. I will define what model I'm going to use. I'm going to use linear regression. Right? I'm going to use linear regression. So I have defined my model. So what I'm going to fit, I'm going to fit x as my input variable and y as my output variable. I'm getting an error. Let's see what is that error. So there is an error here because we need to define. So this will become values reshape -1, comma 1, and this will become values. So now look at, now we are able to run the code because we missed putting these values and reshape over here. So now we have properly defined our array, the x array and the y. Properly we have defined it. And now we are able to. So now I'm going to do the first forecasting. So what is the forecasting here? I'll say y underscore predict is equal to model dot predict. This is a code. I'm going to put my x variable here and I'm going to run the code. Yes, it's working. I'm going to run the code once again. PR is, see, this is my forecast. I'm able to get the forecast now. Y underscore predict is my model dot underscore predict xy. So this is what my forecast I'm able to achieve by using a simple code. Y underscore predict is equal to model dot predict and x is my input variable. Right now, I want to understand what is my error. So I'll write name. So mean underscore absolute underscore percentage underscore error y comma y underscore predict. So this is, if you look at, the error is 19.8%. The error is 19.8%. So this is how we got our error. How much error we have in the forecasting model? 99%, 19.8%. What is the accuracy? The accuracy is almost 81.2%. So with this model, we are going to achieve a forecasting accuracy of 81.2%. How to find accuracy? So I'll write accuracy equal to 1 minus MAP. Right? I'll run the code and write again ACC enter. So this is 80.19. So my accuracy is 80.19%. Right? I'll also find MAE, that is mean absolute percentage. Let's say I'll find MSC, that is mean squared error. So mean underscore squared underscore error. I'll write y comma y underscore predict. These are my two. Enter, write MSC, run. So the mean squared error is 19.30. The mean squared error is 19.30. So now we know what is our error, what is our accuracy, and what is the mean squared error. Right? So now what I'll find is my standard error. So what is standard error? So before going into the standard error, I'll just give a small definition. So in linear regression, the most one of the most important metrics are R square, F stat, T stat, P value of T stat, P value of F stat, coefficient, coefficients of cause variables. But these are the things which you need to find in the linear regression. So let's go and find them one by one. The first I'll find the coefficient of time. If you look at here, the coefficient of time is 0.14. I'll find the intercept. And the intercept is minus 0.37160. So the model, if you want to build over here, so we have to look at these two parameters. Two parameters are, so C is a coefficient. So Y is equal to alpha is minus 37 plus 0.41 into time. This is what the equation we got. So Y hat is equal to minus 0.37 plus 0.41 to t. So we know the intercept. We now know the coefficients. We have to find the standard error. So I'll say S is equal to NP dot square root NP dot sum Y minus Y predicted and I'm going to square up that in Python. For squaring, you have to put two stars divided by, I'll use degree of freedom. So length of y minus 1. So these are square root, this is standard error. Now I'll find the t value. T value is nothing but C by SE, coefficient by standard error. So here we're getting t value as 0.03241. Now I have to find the p value of t value from t value. So I'll just multiply. So I'm doing a two-tailed test. So 2 into 1 minus stats into absolute value of t, comma, length of y, total count of data points, minus 1 minus 1. So I got some error here. Let's see what is the error. Okay, I made a mistake here. So this is stats dot t dot cdf. Now we get a p value. So p value is 0.97. Right? P value is 0.97. So this time is not coming as significant variable. Now I'll find r square. We're getting R of 91%. So this is a very significant equation, but we don't know why we're getting p value of 0.97. We should have got this as a very low value. Maybe if I remove this, if I run this, So now we got your R square value, we got T value, we got P value, we got our standard error. Now we'll find the SSE or SST, which is also called sum of square of error. So y minus np dot mean of y. So SST. So here we have to do some more thing here. Now I'll do np by np dot sum. Right. So this is we will got yp minus. I'll take the square root of this, square of this. I'll write on the code. So we have some problem here. So np minus sum y minus np minus. So we have to put one more closing bracket here. So y minus np minus 1. Now let's run this. So y minus np minus np dot mean of y, np dot sum of np. So I'm putting some extra brackets here. That's a problem. So y minus np. Still we're getting a problem here. So np also square of y minus. So y comma So now we got it corrected. So there's a problem. The problem in the placement of the closing brackets and the opening brackets. Now we got SSTS 7588.4. Now I'll calculate the SSE. So NP minus NP dot sum. So Y minus Y predicted. And I'll take the square of them. So for square, I have to put so the SSC. Let's run this. Let's run this. We got SSC now. And we want to calculate SSR. And SSR is SST minus SSE. So we'll run for SSR. So this is what our SSR, right? So we already have calculated our R square. So I'll put one more sign. So SSR by SST. So we got the same value R square 0.912 from here and 0.912 from here. Right? This is this is from the Python and this is the manual calculation. We're getting the same answers for it. Okay, so we got R square, we got our MSC, we got our SSC, we got our MAD, we got our right. Now what we're going to calculate is F statistic. So for F statistic, what we want to calculate before is mean square error. And for that we will divide SSE by length of Y minus number of independent variables minus 1. So SSE, what we have done before SSE is there, length of Y minus 1 minus 1. So let's see if any, what is the problem in the brackets here? Now it's working. So I'll run MSC underscore 1. So we got 19.42. Now we're going to calculate MSR. So SSR divided by number of variables. That is 1. Now we're going to get F statistic that is equal to SSR, MSR divided by MSE. We're getting a very high F statistic. Right, so this is how we are getting our F statistics also. Now we are going to plot a scatter plot between our X variable and Y variable. Look at here the scatter plot. And what you see over here is there is a trend. As X increasing, the Y is also increasing. As the time is increasing, the sales are also increasing. That's why the model could be, if there is no spurious relationship between time and sales, then I think the model is perfect for building linear regression. We also calculate the error. Error is equal to Y minus Y predicted. These are all the errors we have. Also try to build a scatter plot between the x variable and the error variable. So what we see is some a bit of random distribution we are able to see, but still not a very strong random distribution between the error and the x variable. So we need to work on this model a little bit more because still we see some kind of pattern in the beginning. In the middle, there's a bit of randomness is there. At the end, we see some kind of pattern. So what we want, error has to be random. Means there should not be any patterns over in the error. So I still see this error is not a very strong error. We need to work on this error. We need to make the error white noise. White noise means the mean of these series should be equal to zero. The variance has to be same, and there should not be any pattern in the series. So I still see some kind of patterns in this particular error. So we have to make our error random. So I would like to revise things once again, guys, for you. So first thing, what you have to install your packages like NumPy, Pandas, Matplotlib. You have to install them. Then you have to import some of the import the packages like import NumPy as NP, import Pandas as PD, import matplotlib.pyplot as PLT, and we are using Skylern, sklearn.ini. We're importing linear regression from there. We're also importing the error metrics from the Skylern, and from SkyPy we are actually importing stats, right, to work on the p-value. When we are importing our data, pd dot read underscore excel. So we have to see forward slashes or backslashes, right? So backslashes will work only if you put r. Otherwise, you have to put double backslash, or you have to put one forward slash without r. Then I want to study my data, see what are the different columns are there. So for me, my x variable is sequence and y variable is auto sale trend. So and so I'm defining that here. What is my x variable? That is sequence. What is a y variable? That is auto sale trend. I'm defining and I'm trying to build a linear regression model. So this is what I'm fitting inside model fit x y. Then I'm predicting my future. So this is the y underscore predict model underscore predict using cost variable. This is my predictions over here. Right now, I'm going to calculate my errors. What is the mean absolute error? That is 19%. I am calculating my accuracy. That is 80.19%. I'm calculating the MSC. That is 19.30. Right. Then I'm calculating my coefficient of x. That is 0.14. I'm calculating the intercept. That is minus 0.3716. Now I'm calculating the standard error, that is np dot square root, np dot sum, y minus y predict the whole square divided by the degree of freedom, right? Then I'm calculating the t value, that is t by SE. So t value is 0.032. That is coefficient divided by standard error. Then I have to find my p values. So p value, two-tail p values, so it's coming around 0.974. Then I'm calculating my r square, that is r square r2 underscore score y predict, and this coming around 91%. I'm calculating my SST, which is coming around 7584. I'm calculating my SSC, that is sum of square of error, that is 6642. I'm calculating my SSR, that is SST minus SSC, that's come around 69242. Right, I'm calculating R square again manually, that is SSR by SST, which is coming around 91.2%. Now I'm calculating my mean square error, which is SSC divided by degree of freedom. That's coming 19.42. I'm calculating my MSR, which is the SSR by degree of freedom. We have single variable, that is SSR1. So we're dividing MSR by MSC to calculate our F statistic, coming around 3585. Now we are building up scatter plots to understand. This should have been done in the beginning, but I'm doing at the end to understand what kind of pattern is available, what kind of pattern is available between X and Y. Then I'm calculating my error. After calculating my error, I'm calculating the distribution of error with respect to my X variable. The distribution has to be random. So there's some kind of patterns are there, but also there is a random distribution is also available. Mix of them. So we have to work on this model a little bit more to eliminate the errors. So this is how we can do linear regression in Python in a step-by-step manner. So if you have any questions, you can post those questions on my social media page, or you can also email me. Let me share my email ID and WhatsApp number. So you can also email me to your queries. This is my email ID. You can also WhatsApp me on mobile. This is a personal mobile number, +98977924637. And I also want to update you that we're launching a new training program from 30th of June. So if you want to register to these training programs, please contact on these details. So we have a detailed forecasting program, detailed forecasting and inventory analytics program using Python, advanced Excel, SPSS, and Power BI. These are four tools we are going to provide the exposure to you. So if you want to join, this is a very rich content using machine learning and statistical models and ordinary models. So it's a very rich content. And if you learn this program, you'll become one of the best forecasters in the market anywhere in the world. So if you want to become one of the best forecaster, join this program because we are going to teach a forecasting process, not only just tools and all. We're going to teach a forecasting process, algorithm, step by step. And you don't have to worry if you don't know Python. We'll teach everything step by step. Right now, I have given a demo of how this, but this I have not given you a step by step detailed process. For that, we have to join our training program. So look forward to speak to you on registrations for the training program starting from 30th June. Or if you have any queries also, you can connect with me on my email ID and you can also WhatsApp me or call me. So guys, I would like to take a leave and thank you very much for your patience and participation and look forward to you with more live programs and keep following my group so that you can attend this kind of valuable training programs or valuable sessions live. Thank you very much, guys.